Welcome to Lesson 1-4, Video 3. So, right here, example number 3, we actually don't have any notes here, we're going to just do a couple examples. It says, find the slope of the linear function 3x minus 2y equals 8. Now, one of the things you saw me do in class today is I said, raise your hand if you've seen this equation, y equals mx plus b. Okay, most of you all have seen that. This is actually a linear equation, and like y'all said in class today, because it tells us that it's linear, and the question I asked was, how do I know that this is a linear function? Well, if you look at the x value, the x is actually being raised to the first. Now I know they don't write a first power there, but it is assumed to be a 1 if there's no power there. So anytime you have a y equals equation, where you have y and x in your equation and x is to the first power, it is going to be a linear equation. And similarly, this equation over here is not linear. It is actually a quadratic equation because x is raised to the second power. So we'll get to this one in a second, but let's go ahead and solve this. So I'm going to start by writing this a little bit bigger. So 3x minus 2y is equal to 8. So the first thing that you need to do is you need to think, I need to get this into slope-intercept form. Because if it's in slope-intercept form, then I can easily look at it and see, oh, there's my slope right in front of the x. In order to get it into slope-intercept form, I must get the y value by itself. So this is what I'm going to have you do. So the first thing I want you to do is circle negative 2y, and I want you to draw a vertical line through that equal sign. Okay? So we do not want to touch this right now. We want to get y by itself. And right now the negative 2 is with it. So we want to do something to this 3x first. So this 3x is a positive 3x, which means it's being added to this side of the equation. So in order to get it to the other side, I must unadd it or subtract it from both sides. And you'll see that I'm going to write it as minus 3x here and minus 3x over here. And I purposefully wrote this not lined up with the 8. And I did that because these are not like terms. You cannot combine these. So 8 minus 3x is not 5. Do not do that, okay? These are not like terms. We cannot combine them. So I know that the 3x and the negative 3x cancel. So I'm going to bring down my negative 2y. So negative 2y goes here, equals. Now these, like I said a second ago, cannot combine. So I'm going to go ahead and write this, though, as 8 minus 3x. Now we're getting closer. So now we have y on the left-hand side. It's almost by itself. But I see that I have an 8 and a negative 3x here. And looking up at my slope-intercept form up here, I have an mx that's first. So I'm going to start by my next step by rewriting this as negative 2y equals negative 3x plus 8. So all I've done is I've flipped these two, and yes, you can totally do that. For example, 2 plus 3 is the same thing as 3 plus 2. Okay, they both equal 5. I'm just rewriting it so that I have x first. Now, to get rid of the negative 2 in front of the y, negative 2 is actually multiplying y. Y is being multiplied by negative 2. So let me go change colors again. So in order to unmultiply a value, I need to divide by that value. So I'm going to divide every value by a negative 2. Let's scroll down here just a little bit so we can see. So these are now going to cancel, and I'm left with y by itself, so I'm going to bring that down, equals negative 3 divided by negative 2. A negative divided by a negative is a positive. So we're going to write this as 3 over 2. Go ahead and leave it as an improper fraction. That's okay because I can easily identify the slope. In fact, we can now answer this question. What is the slope of the line? I can see that that number in front of the x is a 3 over 2. Okay, so this is my answer. But let's go ahead and finish it here. Plus 8 divided by negative 2. That's going to give us a negative 4. So this is my equation in slope-intercept form, and this value in front of the x here is what my slope is, 3 over 2. All right, so that's 3a. Now what we're going to do is dive into 3b. And if you do not have one of these at home, these calculators here, I highly recommend you get one, or just make sure you take notes so that when you get to school and you're able to use the yellow calculators that look like this, they are the exact same, okay? But you need to know these steps, okay? And I'm going to be using this calculator, which is the same calculator. It looks a little different, but it's all the same buttons. So we're not going to do this one by hand, okay? Let's start by reading it. Okay, so it says determine the average rate of change from x equals 1 to x equals 2, given the function is f of x is equal to x squared plus 2x minus 7. So we need to figure out what the values of y are for each of these values of x that they give us here. So let me circle these for you. We need to know what the value of y is for x equals 1 and for x is equal to 2 so that we can find the rate of change. There's an easy way to do that on the calculator. So we're going to start by going to table, so click table, and my equation's already plugged in, but you need to go ahead and click clear once you hit table, because there's probably going to be an equation already plugged in that you need to clear out. Then we're going to hit x, the variable button, and then we'll square it, plus 2x, we're going to plug this equation straight into the calculator after hitting the table button, minus 7, and now we have our equation from right here plugged in. And we'll hit enter, and mine says start at 11. I'm going to change it to 0. All that does is tell the calculator where to start displaying values. So it's going to start displaying values whenever x is 0. And the step is just referring to the increment it's going up by. So when x is equal to 1, 2, 3, 4, 5. If this was a 2, it'd go up by 2s. If it was a half, it'd go up by halves, like 0.5, 1.5, 2, or 0.5, 1, 1.5, 2, 2.5. Leave this on auto, and we'll go down to OK. Hit enter. So now we've got a list of values, and notice you can scroll up. I'm scrolling down here, and it's giving me all the output values of y for every value of x that you plug in. And specifically, we're looking for x is equal to 1. So right here, when x is 1, y is negative 4. So I'm going to write that down. So when x is equal to 1, y is equal to negative 4. And my ordered pair would be 1, negative 4. And when x is equal to 2, right here, so when x is equal to 2, y is equal to 1. So my ordered pair would be 2, 1. So now we have our ordered pairs, and now we just need to remember our formula, which is delta y over delta x, our rate of change formula. So recall that's y squared minus y1 over, I'm sorry, I said y squared, y2 minus y1. It is not y squared, it's y2 minus y1 over x2 minus x1. So we're just going to plug this straight in. So we'll call this my x2 and y2, and we'll call this my x1 and y1, and we'll just plug it right in. So 1 minus a negative 4 and 2 minus a 1. That gives us 1 minus a negative 4 is like 1 plus 5, or 1 plus 4, which is 5, and then 2 minus 1 is 1. So my slope along this interval, my rate of change, is equal to 5. Now there's one more way I want to show you with this, and that's with using Desmos. So we're going to go over to the graphing calculator of Desmos, which looks like this, and I'm going to plug my equation in the way that I see it right here. So remember, you can access this by going to Google Classroom. This needs to be the testing version of Desmos, and we're going to plug this in the way we see it. So you can plug in y is equal to x squared plus 2x minus 7, and it's going to plot our graph. But if you click this little gear icon and then click the table, it will give you table values. Now it's not as intuitive as going over to your calculator and scrolling up and down. I see it's going to give me all the values I want without having to plug any values in. But over here on Desmos, it's going to give me a set of 5 values. So let me move this over here. So if I wanted to get whenever x is 3, you just plug it in, and then whenever x is 4 or 5 or 6, and you can plug in all those values and get your inputs and your outputs. Alright, that is all for video 3. Go ahead and take a second and try the U-tries, and then I will see you in video 4.